Comparing every document pair explodes quadratically. MinHash estimates Jaccard similarity, and datasketch LSH turns near duplicate detection into a fast indexed lookup. You'll understand the pattern behind a pipeline that finds near duplicates without checking every pair. I'm Professor Pi, teaching AI foundations with simple Python. If your dataset has thousands or millions of documents, pairwise checking becomes impractical fast. Near duplicate detection is about finding documents that are almost the same. Copied news stories, similar product descriptions, lightly edited spam. MinHash plus LSH gives you a cheap, sublinear way to find likely duplicates first, so you only do exact checks on a short list. It scales far better than brute force, and slots cleanly into small Python services or batch jobs. The core pieces are simple. Jaccard similarity measures overlap between two token sets. MinHash turns a token set into a compact sketch that preserves that overlap approximately. LSH buckets similar sketches, so a single query returns a short candidate list instead of scanning everything. The trade-off is approximation. You get speed, but you still need verification for final decisions. We'll build a tiny pipeline end-to-end. An exact comparison, a MinHash sketch, an LSH index, candidate generation, verification, and a function that checks a new document. That gives you a pattern you can scale up. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. We start by showing why naive pairwise checks are a problem, and what exact overlap looks like for two small texts. This snippet measures one exact overlap score between two tiny documents. Pairwise comparison starts innocently. Split each document into tokens, turn those tokens into sets, and compute shared words over total unique words. The variable tokens keeps the document representation simple and visible, while score shows the Jaccard-style overlap for doc1 and doc2. This is useful intuition, but it also hints at the scaling problem, because doing this for every document pair grows fast. The visible output shows a high exact similarity, which gives us a target behavior for near duplicate detection. Now we avoid carrying whole sets around by compressing them into sketches. This example uses datasketch MinHash to compress each token set into a fixed size signature. Instead of carrying every token into every comparison, Sketch builds a MinHash with numperm 64 and feeds bytes through update batch. Sorting the words is not required for set meaning, but it keeps the on-screen transformation deterministic and easy to inspect. More permutations usually give a steadier similarity estimate, while fewer permutations use less memory and less update work. The visible output shows that doc1 now has a compact signature, which is the object datasketch will index next. Sketches are great, but we still need a fast way to find nearby sketches without comparing to all of them. This code builds a datasketch MinHashLSH index and asks for likely neighbors of doc1. The key change is that LSH.insert stores each MinHash once, and LSH.query uses the index instead of scanning every pair manually. Threshold 0.7 says we care about fairly similar token sets, so doc2 should be a candidate, while the log document should not matter. Raising the threshold makes the index stricter. Lowering it can return more candidates to check. The visible output shows the candidate set, which is the fast shortlist we wanted. Approximate indexing is fast, but not perfect, so we verify the shortlist with the original tokens. This snippet verifies the best datasketch LSH candidate, instead of trusting the shortlist blindly. MinHashLSH is designed to be approximate. So cans removes the query document itself, and ranked recomputes exact overlap only for the small return set. That gives you the speed benefit of LSH query while still using the original tokens when the final decision matters. In larger systems, this same pattern becomes candidate generation, followed by a cheaper verification pass. The visible output shows the best matching document and its checked score, which makes the result easier to trust. Finally, we turn the pieces into a tiny detector that handles a new incoming document. This example turns the pieces into a small data sketch, near duplicate detector for a new document. New words represents the incoming text. Sketch creates its MinHash, and LSH.query pulls only likely existing matches from the index. The dupes list then applies an exact cutoff on the original token sets. So the final answer is not just whatever the approximate index returned. This is the baseline shape engineers can scale. Sketch, query, verify, then decide. The visible output shows which existing documents are near duplicates of the incoming one, completing the mini workflow. In a real project, you map these steps to a data store and a background job. Sketches and the LSH index live in memory or on disk for fast queries. Verification uses the original token sets stored in a compact form. Here's the takeaway. Use sketching plus indexing to approximate Jaccard and cut your candidate set dramatically. It's the right tool when you need sublinear near duplicate detection across lots of documents. But remember, the index is approximate, so always verify candidates with the original tokens before you act. A useful next step is to tune the two knobs you already saw, num_perm, which starts at 64, and the LSH similarity threshold, which starts at 0.7. Increase num_perm for more stable estimates, and tighten or loosen threshold to trade false positives for recall on your actual dataset. If AI Foundations in Python help, subscribe and watch the AI Foundations videos.